Oh, not bad, not bad. So there is, oh, there's Kate. All right, hello, Kate. We're doing a Kahoot here. The pin is in the lower right corner if you want to join us. So when you have any two intersecting chords in a circle, if you take these two pieces, 9 times 5, it will be the same as these two pieces multiplied together. So x times 15. So 9 times 5 is 45. So 3 times 15 is also 45. So x comes out to be 3. And by the way, they always tell us when you guys are taking tests and stuff that images are not drawn to scale, and they're not necessarily. But sometimes if you have no idea, they are. I mean, it's better to guess that way than to just totally guess off the wall. All right, so this is okay. I thought they had the wrong answer. Okay. For this one, if you have two intersecting chords, these angles in the middle here, they're the average of these two. So you add them together and divide by 2. So 160 plus 50 is 210. Divided by 2 is 105. And so each of those is 105 degrees. And you might want to, if you're trying to estimate that or think about it, like if this point, as that point moves closer to the 50, that angle gets larger and larger. And then the angle here, E, as it moves further away from this side, it gets smaller and smaller. Okay, but those angles in the middle there, they are the average of the two arc angles out here. All right, so this is good. We're just hopefully learning a couple of these axioms for you guys, or rules. All right, now for these, so like in the previous one, if the two chords intersect inside the circle, you add them and divide by 2. If they intersect outside the circle, you subtract and divide by 2. So 80 minus 20, of course, 60 divided by 2 is 30. Okay, so they intersect inside the circle, you add them. Intersect outside the circle, you subtract them and divide by 2. Oh, excellent job, guys. There you go. So looks like you guys have learned. But this angle is half the intercepted arc. So the intercepted arc is twice 68. All right, you guys are good. All right, so using the idea we did in the last one, if this is 68, this is 136 from P to N. Notice that this is a diameter, therefore from P to N to M is a semicircle, is 180. So if you did 180 minus 136, you get 44. All right, so don't worry if you guys are getting these right or wrong. You know, we want to use this as a learning tool. So this is a common thing. If you put together the things that we talked about before, we're trying to find this angle right here. Well, notice that angle goes out to P in this direction and out to M. This is a semicircle, which is 180. And remember, this angle then is going to be half of that. It's going to be 90. Just using that same rule when we had the 68 and 136 over here, same thing. It's half of the intercepted arc. Okay, so it's 90 degrees. All right, there we go. Right, you visualize. Well, in the central angle is the same as the arc, so this is going to be, this arc angle is 60 degrees. So the inscribed angle is going to be half of that. It's going to be 30 degrees. All right, this is a quick one here. Very good. The radius is going to be, your x value is 5, your y value is -8, and your radius is, I think I said radius, center is 5, -8. The radius is the square root of that, which is 3. So good job. All right, good job, guys. There you go. So CDE, if this 140, the whole circle has to be 360, of course. So CDE would be 360 minus 140. Why are the angles? All right, very good. So these two angles are both congruent because if you follow the angle out, they both intercept this arc. They both intercept 124 degrees. So they actually both would be 62 degrees. They'd both be half of the intercepted arc. All right, last one here. All right, so I'm going to pull up my iPad and we'll take a look at that 1516 test from Schoology. There we go. All right. I'll tell you what, I'm going to get you guys started with the first one. Then I'm going to let you do some of it on your own. And then we'll all come together in a couple of minutes and talk about it. So first question here. This, by the way, this was the actual test from 2015. I think this was non-calculator. These numbers look pretty easy to me. I mean, when I say easy, I'm saying like they're integer whole values. So typically that's an indicator. So let's take a look here. We have two concentric circles. If you don't know what concentric circles are, you don't have a chance of doing the problem. It just means like a bullseye, one inside the other, perfectly inside, kind of. So they have the same center. So two concentric circles means this. Means you got one circle on the outside. And a circle on the inside. All right, so two concentric circles. Let's see. Such that the area of the inner circle is equal to the area of the region between the two circles. So that means the area of the inner circle, so like this yellow part, is equal to this yellow part, okay, the area between the two circles. So it says if the diameter of the inner circle is 6, that's big news. So that gave us the diameter of this, that's the radius, of course. Well, I'll just leave it as a radius. So if the diameter is 6, the radius, of course, is 3. Which means we can quickly find the area, right? The area of the inside circle is going to be 9 pi. We know that that's 9 pi. But that's not what they're asking. They're asking for the diameter of the outside circle. So I'm going to leave you guys then with this part. Let's call that diameter. If this little piece was x, then the diameter would be x plus 3. All right. Try and write down some ideas. We'll take just a couple minutes, and then we'll try and put our heads together to figure this out. I'll bring everybody back in about 2-3 minutes. All right, guys, now's your time to shine here. Come on, give me some ideas.
Instead of doing anything with x plus 3, I realized that if the small circle was 9 pi and the bigger circle was also 9 pi plus 9 pi is 18 pi. So you can just do pi r squared equals 18 pi and get the answer.
Oh, that's awesome. Good for you. So you said, we know this is 9 pi, and let me make sure I'm following you correctly, because that wasn't how I thought it through, but yours makes perfect sense and probably is easier. That's 9 pi, and that's 9 pi, and we're going to take that plus that. That means the area of the whole thing is 18 pi, right?
Yeah.
So if we know that the area is 18 pi, and we know the formula for the area is pi r squared, means the radius is the square root of 18. All right, awesome. Good job. Any other ideas there?
I did the same thing as Lena.
All right, good job. Yeah, and so obviously that's the radius. So with diameter, we'd want to double that, right? And you should write your answer. You know, we'd want to do one of these guys. Okay, that's going to be 3 root 2, right? You guys want me to write that out? Or are you okay with simplifying that radical?
We're fine.
Okay. So, you know, then we double that. So 6 root 2 then would be our diameter, because we would double that. Good. Because I actually did write it out, but of course you get the same thing. So I said that, you know, if the outside radius was x plus 3, so I did pi times radius squared, pi r squared, and then minus 9 pi, and then that equals 9 pi equals the middle part, and then you solve that for x. But I think your way is much easier. All right, good job, guys. All right, let's try a second one here. So A, B, and C are 3 points on a circle with AB 8, BC 6. So let me just start by drawing a circle here. So A, B, and C around the circle. AB is 8. BC is 6. And AB is perpendicular to BC. All right, so we're trying to find the length of arc AC. We're trying to find this length here, not angle, but length. All right, take it from there, guys. How about we'll take 3-4 minutes, try and find that length. All right, let's see if we got any ideas on this one.
What I did is I like made a line from like A to C
Okay.
because that's the diameter of the circle, and you know that's
Whoa,
10
hold on now. How do you know it's the diameter?
because there are 3 points on a circle, and B is a right angle and AB is perpendicular to BC.
Okay, and you're correct. I didn't mean to try and stumble you up there, but it's really important that this is a right angle. If that's not a right angle, it's not necessarily a diameter. So, and you're
Yeah.
right, Kate. Perfect. So that green segment is a diameter, and that only happens if those are perpendicular, because it gets back to that idea we talked about before. If that's 90, the opposite angle is twice that. That's 180 degrees, which is half the circle, which means that AC has to be the diameter. All right, you're on a roll. Keep going, Kate.
So you know AC is 10 because it's a 3, 4, 5 triangle, like 6, 8, 10.
Bingo.
And then, so you know the circumference of the circle is 10 pi. And since arc AC is 180 degrees, it's half of the circumference, so it'd be 5 pi.
Yes, very well done. Very well done. So it's a 6, 8, it's a 3, 4, 5 triangle doubled. It's a 6, 8, 10 triangle. So 10 is going to be the diameter. Circumference is diameter times pi. So the circumference of the entire circle is 10 pi, which means the circumference of half of it, of course, would be 5 pi. So nice job, Kate. Let's take a look at this next one here. In the following figure, the two circles with centers C and D are congruent with radius 4. Oh, it's already drawn on there. AB is tangent to both circles. One property we haven't talked about yet is tangent lines at their point of tangency. And this may or may not be relevant in this problem, but it's important for you guys to know that a tangent line at its point of tangency, if it intercepts the radius, where the radius and the tangent line intersect, is a right angle. The tangent is perpendicular to the radius. Okay, so that's a right angle, and that's a right angle. So let me go back to what we were saying before, but that property is an important one. It comes up quite a bit, that tangents are perpendicular to the radius at the point of tangency. All right, so it says the two regions denoted R and S, so those two little chunks in there, okay, are equal in area. What is the area of quadrilateral ABCD? So we want the area of the quadrilateral, which is actually a rectangle. And all right, so how about if you guys, I guess there's not much for me to write on here, but why don't you guys take a few minutes, try and come up with some ideas. We know, and I think this is really important, the two regions, they wouldn't tell us if it wasn't important, R and S are equal to each other. Okay, ideas, thoughts?
So since area R and area S are equal,
Mm-hmm.
I kind of figured that the line that goes through, like the line that intersects them, has to be halfway through that arc there, and that arc is 90 degrees because it is a fourth of circle D or circle C, depending on which one you look at.
Okay.
So that's an eighth of the circumference, right? Like the
Yeah,
section.
you're saying that part.
Yeah, that part is an eighth of the circumference, which is 8 pi. So that right there is 1 pi. And since it's double that, it's 2 pi for the entire area or the entire line AB. So that's what I did.
All right, but if you're looking at, so I think what you're describing here is that arc length, correct?
Yes, correct.
Yeah, so, but we want to find, I think we want to find the area of the quadrilateral.
Yeah.
So and maybe I'm missing something. Did we get to the area from that?
I mean, I just like.
Or you're just trying to find,
Oh, I got the area from that, but I just like. I took it as since that arc is 1 pi, I took it as that was equal to half of AB because it's half of AB. So I just multiplied that by 2. I don't know. It made sense to me.
Okay. Well, I think what you're missing though, it's not necessarily going to be half of that side, I don't think. All right, other ideas. Thank you, Andrew.
I did, the rectangle is half of a circle because it has like a quarter of the circle, except S is like overlaps, but then you can just substitute R for S one of the times because they're both equal.
Okay.
And then the area of one of the circles is 16 pi. So since the like rectangle is half the circle, it's 8 pi.
Is 8 pi. Okay. So what you're saying is, if I'm following you correctly, who said that, Kate? Okay.
Yeah.
So since right, this is obviously a quarter of the circle. And if we take R and know that it's the same size as that, then we get another quarter of the circle here. And so then those two pieces together are half of the circle. And since the radius is 4, the area is 16 pi, and half of that would be 8 pi. All right, excellent. I'm with you there. Good, very good, very good. All right, other ideas. This is good stuff. No? Okay, so we had some really good idea, and 8 pi is the correct answer. So great ideas there, guys. Good job. And I did it with the area too. The key that this and this are the same, therefore I found that, and then I found that, realizing that it's the same as the little wedge plus R, and then added the two together. All right, we're on a roll here. Let's see, 10 after 4. All right, let's do another one here. Let's try the next one. In the following figure, AB is a diameter, length 10. AD is tangent. So remember, we talked about some tangent properties already. We know that BC is 4. So that's 4, and that's just from there to there. What is the length of CD? So we are trying to find X. And we know that the diameter is 10. All right. I'll give you a couple minutes to chew on that one a little bit, and then we'll talk about it. All right, we're kind of getting really close to our 4:15 time here, so maybe we get some ideas on the board here for number 4. Thoughts for us? No? right. What do we know about this triangle here?
It's a right triangle.
Perfect. Got to be a right triangle, right? Because what we talked about before, that at the point of tangency, the tangent line is perpendicular to the radius. All right. So, but we don't know this, and that kind of threw me for a loop at the beginning, because my sides, I have 10 squared plus y squared is equal to x plus 4 squared. All right, makes sense so far? Now there is one property, and I don't, maybe we didn't talk about, we kind of talked about it. We talked about a version of it. Remember we did in the Kahoots, we had, I think we had these, oh no, we did the arc angles when we had the two that intersected there. I'm sorry, so we didn't talk about this property. In this case, you have this secant line. It's a secant line because it hits the circle in two spots. And you have this tangent line. And when you have two secant lines, maybe I'll start with that. The pieces A times B is equal to C times D. Okay, kind of like those chords that we had when they intersected inside. Okay. I'm sorry, I said that wrong, my mistake. It's A times A plus B is equal to C times C plus D. So it's the, A times A plus B is equal to C times C plus D. That rule applied here is the same idea, except that's not a secant, it's a tangent. So what happens is we get 4 times 4 plus x is equal to y times y, or 4 times x plus 4 is equal to y squared. Okay, so that's another one of those kind of rules to tuck away. But now what's nice is I now have 2 equations and 2 unknowns, right? We can make a system out of those guys and solve it. Using this system, it's probably, because we know that y squared equals something, probably best to do a substitution here. So I get 10 squared, which is 100, is not equal to 100 plus. Remember, y squared now is going to be that, which is 4x plus 16. And then that equals the quantity x plus 4 squared, which FOILed out as x squared plus 8x plus 16. Okay, and we can solve for x. And that's what we're looking for CD. All right. The last one, I know I'm already running over. I'm sorry, guys. I appreciate you guys being here on this short week. There is one thing that's kind of important on this last one. This is, a pretty kind of famous type of problem where you have this conveyor belt type of situation around these 2 circles of radius. What are they? 2 and 6. So that's going to be 2. And this guy's going to be 6. And using that idea that we talked about before, remember, those are perpendicular there. Okay. And so we get this kind of crazy looking shape here. That's 6. And that's going to be 2 also. So I'm just going to give you one big hint here, because, a lot of times the problem is tried this way. But one thing that is imperative in solving this problem is making this top part into a rectangle. Oops. Wasn't a real good line there. It's supposed to be parallel to that top line. Sorry, guys. There we go. Okay, making that top part into a rectangle, so that splits that up into 2 and 4. And I'm going to leave you with that. We've got a 90-degree angle, and there's a pretty good explanation there in terms of a 30, 60, 90 triangle that we get. Because the green segment, remember the green segment here, we know that that's 6 and that's 2. So that's a length of 8. So it creates a 30, 60, 90 triangle in the middle there. All right, before I wrap up, is there anything else you guys want to talk about?